Hello, this is code overview for our clock. I choose clock state as a code snippet. The clock state work as FSM with four parameters: current time, set alarm, and set time format. And each of them has 2-bit representation. So every time I press switch, it will go from one state to the next one like topologically. I also want to indicate the current time state is set as a background, so the clock will keep ticking unless we turn the entire AAU off. The current time, which is the background, send three outputs with different bit width, since our has 24 maximum and 60 for second and minutes. And if we go to set time, so this is interesting part. Set time, set alarm, set time format. We choose to use another FSM. So it's basically FSM within the FSM. The reason we choose this technology is that we have to set the time. We have to set the hour first, and then minute. And if we're done with that, it moves to second. So I think this represents basic knowledge of FSM. And also, for set alarm, we have additional output and input, which is stop, switch, and alarm. If they match, if they all go high, the alarm will be off and go low. Lastly, for set time format, we have additional 2 bits output ECPM, which determine the clock system is 12 or 24 hours. When the clock is 12 hours, it also determines if it's AM or PM.
Hey Rashmi, so I'm just gonna quickly show you our clock, which is gonna start up from 1 there. Sorry, that's our alarm. It was set for a minute, it already went off, so it's gonna stay on unfortunately. But as you can see, the clock is counting up from 1 there at exactly 1 second per second. Alex also did some VGA work, so that block rectangle will go up by 1 for every second, and then a second one will go up by 1 for every 10 seconds, and then another for every minute and every hour, which ends up looking kind of like that. Eventually we just grabbed a screen grab of it because we're not going to count up that high. I can also set the time on here, so I'm just going to reset it. Setting the time also resets it, so I already have it set to 5:45, but I can change that 1:44 or whatever really I want to set it to, and then turn that off, and it'll start counting up from there. So yeah, this is also the format button, which I guess you can't really tell that it's the format button right now because yeah, it basically makes it so that it'll either count up to 12 and then reset, or count up to 24 and then reset. So yeah, that is pretty much our clock functionality. Was there anything that you wanted to add?
No,
Alex killed it with the VGA anyway.
I have fun with the VGA.
Yeah. So we'll move on to discussion. All right, so it's Paige and Alex doing discussion in the lab quickly. So yeah, that was a fun lab. It ended up actually being a little bit easier than the other ones, just because
we
I don't know, more
could see the result.
Yeah.
Either the clock or the VGA. We could see what we were doing.
It was really easy to check. Of course, Alex is getting more and more experience with the VGA, so he's killing it on that. Although it was still, I think, the hardest part. We were working on that for like...
Yes, it was very long to understand how VGA worked, with more than just a square that changed colors. This time I had to make multiple squares change colors, and that was very hard for me.
Yeah, no, but you killed it. And then linking it up with he made an output that really worked well with, or made an input that worked well with my output, so I could take our top module and just output the bits that we needed to update the VGA clock, and then the VGA would update for the most part. So, yeah, it was fun.
Yes, definitely.
Final project, let's go.